Hi everyone, today's lesson is on derivatives, the product rule and quotient rule, and also I'd like to talk just briefly about the higher order derivatives. So the product rule says that if you are multiplying or taking the derivative of a product of functions, that this is the rule that you would follow. F of x times the derivative of g of x plus g of x times the derivative of f of x. So in the book it actually had it written this way. It might be a little bit easier. So if you have a function f times a function g, if you multiply the function times the derivative of the other function and then take the second function and multiply it by the derivative of the first, this might be a little bit easier for you to read or make sense of. Okay, so here's an example that we're going to use. I have 3x squared plus 7 times x squared minus 2x plus 3. So I'm going to just call this first function f and the second one g. I think people get a little intimidated by the formula, but if you think about it like this, you have two polynomials that are being multiplied by each other. We're just going to pick one and say you're going to be the first function and the other one is going to be the second function. So the formula says take the first function, so 3x squared plus 7, and multiply it by the derivative of the second function. So that's going to be 2x minus 2. Then add to that the second function, x squared minus 2x plus 3, and multiply that by the derivative of the first function, which will just be 6x. Okay, so I'm going to do this multiplication out. I'm going to, of course, do multiply these and then multiply these and then combine like terms. And we're going to get 6x cubed. Remember, I'm doing FOIL method because I have two binomials. Minus 6x squared plus 14x minus 14 plus. Now I'm going to do the other pair of polynomials. This is going to become 6x cubed minus 12x squared plus 18x. Now I will combine like terms. Between these I get 12x cubed. I get a minus 18x squared plus 32x and minus 14. And so the last piece of this is just that. I can factor out a 2, so I'm going to go ahead and do that. 2 can come out of all of these. So to put it in its simplest form, we're just going to factor this out. That will be 9x squared plus 16x minus 7. I think if you look at this and work through a few of them, you're going to realize that it's really not as long as or as bad as it seems. Okay, so here is the quotient rule, which is very similar to the product rule. What I do want you to notice is in the product rule, we used f of x times g prime of x and then g of x and f prime of x. In the other rule, we used, this one was in the front and we added it to this one. Now we're just flip-flopping those in the positions. That might help you remember the rule. So I'm going to just show you from the book this little shorthand that they did. So the function g times the derivative of f minus the function f times the derivative of g all put over g squared. The other thing I'm going to want you to notice is when we're working the example and when you're working, if you can simplify a function from top to bottom, you will. Otherwise, you're going to leave your function squared as is in the denominator of this derivative. It's just the way that we do that. The example we're going to go through, I'm looking for the derivative of the function x squared plus x minus 1 over x squared minus 1. So using the function, we're going to take, I'm sorry, and I want you to remember that this up here is f and this in the bottom is going to be g. So I'm going to take x squared minus 1 times the derivative of the numerator, which is 2x plus 1. Remember, the derivative of x is always 1. And then I'm going to subtract to that the function in the numerator, function f, times the derivative of the denominator, which will be 2x. And I'm going to put that whole thing over the denominator squared. Okay, so now I'm going to work out the distributive property between the two pairs of functions. I'm going to get 2x squared plus, I'm sorry, that should be x cubed times plus x squared minus 2x minus 1, and then minus 2x cubed plus 2x squared minus 2x. Okay, and then that's all going to go over the denominator, but I'm just going to rewrite this again and take care of distributing that negative on the outside of the parentheses. So this is going to become negative 2x cubed minus 2x squared plus 2x. Okay, and then my 2x cubes cancel out. One of the x squareds cancels out. The minus 2x and the plus x cancel out. So I'm left with a minus x squared minus 1 over x squared minus 1. And then remember, I'm going to square that. That's what the bottom says to do. So I'm going to, at first you might feel like, oh, I can simplify that with what is down below. But you really can't, because when you take the negative 1 out of there, this actually becomes plus 1. And that will not simplify with the minus 1 squared down below. So here is your answer, and notice that I'm leaving this intact exactly the way it is. Okay, so the last thing we're going to talk about is higher order derivatives. So somebody actually mentioned this in class the other day about taking the derivative of the derivative, and we are actually able to do that. So if we took the first derivative of each of these, they would be labeled something like this, the same thing. We can actually take the derivative of these derivatives. Actually, that wouldn't be, and it would be called the second derivative. This would be f double prime of x. This would be the second derivative of y with respect to x, and this would be the second derivative of the function of f of x. We could also take the third function. I'm going to not go through all of these this would have 3 primes. If you did the fourth function and then anything beyond that, we actually just put a little number up there, like an exponent in the function. These always just increase d to the third over d, x to the third, etc., etc. You're adding 2 to each here, then here it would be 3, 4, etc. So here's an example when we are looking at some sort of physics problem, like if we're dropping a ball from the top of a roof. So these are typical formulas. S of t refers to the position function, where how high something is at a given time. And so if we did this, if we took the function here, S of t, and then took its derivative, that would give us the velocity function, but it would also be the first derivative of the position function. And then if we wanted to figure out the acceleration, we would take the derivative again of s prime of t. So we would have the second derivative of s prime of t here, which is also the first derivative of the velocity, and it is the position, the acceleration function, all equal to each other. So I hope you see how this is the first function, this is the first derivative, and this is the second derivative, all of the same function. So let's just do a quick example of this. If I had s of t and it was equal to negative 16t squared plus 100t, and then I took the I wanted to figure out the velocity, so I took the difference of the first one, so I would get negative. Remember, the negative is not attached to the 16. It's sitting at the front of the problem. So we are not going to get rid of it because we're squaring something. This is the first derivative of s of t. This is also our velocity. And then s double prime of t would be just negative 32. And remember, the derivative of a constant is 0, so we wouldn't be adding that. And this is really just all about taking a derivative of a derivative, and as you can see, as we're working our way through, each time there are less and less of the variable involved. Okay, everybody. This is everything we needed for homework. You actually are not doing the higher order piece for homework, but we will take a look at that in class.